so either using the there or distributing, right? So t times t is t squared. T times 2 is plus 2t. 4 times t is plus 4t. And 4 times 2 is plus 8. When you combine like terms, you get t squared plus 6t plus 8. So this is how I do it. If you like using the square method, you can do it that way. Yes, those are both the same. So they all work. So here, you get x times x is x squared. You get x times 2 is plus 2x. You get negative 3 times x is negative 3x. You get negative 3 times 2 is negative 6. You get x squared minus x minus 6. Over here, n times n is n squared. N times negative 3 is negative 3x. Negative 5 times n is negative 5. And negative 5 times negative 3 is plus 15. You get n squared minus 8n plus 15. Please make sure that you have 1, 2, and 3, the original problems, the binomials. Please make sure you have the answers as well, and you're going to use them. So please make sure you have that all copied down. Anyone need more time? I think we're good. I get any reaction. So what I'd like you to do is looking at what's on your paper, looking at the product, right, our answers down here. Please discuss with your partner, take about a minute, what do all three problems have in common? What do all three problems have in common? Go ahead and finish up your conversation. And if I can have your attention, please. Allison, what's one thing that you guys talked about? That they have variables in them? All right. Alan, what's something you guys talked about? They all use the distributive property. Very good. Which I'm going to abbreviate a little later. All right. What else do they have in common? Landon, what did you guys talk about? What, do you know what kind of polynomial they are? Okay, they are all polynomials. Just what kind are they? They're all trinomials, because there are 3 terms of each one thing. Sean? They are quadratic, right? They're all to the second degree. They're all second degree. Did anybody want to mention anything else about them? Those are the important things to take away. The most important thing to take away is right here. That they are quadratic, they are second degree trinomials. You should probably write that down. What they have in common, they are second degree trinomials, they are quadratic. So you found those 2 pieces of information. Second degree trinomial and quadratic. Second degree trinomial, yep. And they're also quadratic. here's what I'd like you to do next. If I have your attention, please. What I'd like you to do is I'd like you to look back at the first one. Look back at the first one that we did here. And what I'd like to know is, you can discuss this amongst yourselves, what do you notice about the middle term right here, and the constant? And what do you notice about the end term and the constant? Go ahead and mumble about yourself. All right, go ahead and finish up. If I have your attention, please. And thank you. Same set of questions about the next one. Once again, looking at this one, what do you notice about the middle term and the constant? And what do you notice about the end term and the constant? Once again, mumble. Go. If I have your attention, please, and thank you. And once you know, we're going to take a look at the third one we did for Bell. Once again, what do you notice about the middle term and the constant, the end term and the constant, and try and write something down for both those questions. Try and write something you figured out based on all three examples that answers those questions. What do you notice about the middle term and the constant? What do you notice about the end term and the constant? And go ahead and write something down. Yeah, write it down. No, just write down like your answer. You have to type too much and teach you to. Might have your attention, please and thank you. Does someone have a way, very concisely, that you can state for all three, what did you notice about the middle term and the constant? What did you notice about the middle term and the constant? Enrique? Well, don't run somebody's thunder, okay? I know. So, how do you get the end term, and what's the difference between the end term and the constant? What's the difference between the end term and the constant? Yes, Allie? When you multiply the constant. You multiply. So, the thing that you need to recognize is that you multiply the constant to get the end term, you add the constant to get the middle term. Alright, this is basic number thinking. So nice job, like most of you had some better understanding. So if you were to write me down, I would make sure that I had this part written down and this part written down. like I said, we have been doing and using the distributive property. And what we're going to be talking about for the next 3 weeks is what I'm going to call undoing the distributive property, which is called factoring. So if you were going to write something down, let's write it down. Factoring, colon, is undoing, with quote, the distributive property. All right, that's kind of an easy way to think about it. It's undoing the distributive property. So factoring, colon, is undoing the distributive property. So factoring is undoing the distributive property. The undoing. Yeah. Once again, factoring, we're going to think about it as undoing the distributive property. Undoing the distributive property. All right, moving forward. So let's take a look at our first problem for today. X squared plus 10x plus 9. So x squared plus 10x plus 9. So think about what are you going to have? What is it going to have to factor down into to be able to multiply two things? What is it going to factor down into so it can multiply into that? Like we're undoing the distributive property. So think about all the bell work problems, all three of them. What did all three of them have? What do they have in common? What did all three? They have parentheses. How many sets of parentheses? Two sets of parentheses. So a factorable trinomial is going to factor down into two binomials. It's going to factor into two binomials. That's what we're going to do. Just like Justin said, we're going to write our two parentheses. That's going to be our first step. Nice and easy. So then, remember, we're undoing the distributive property. So look back at all three of your bell work examples. And when you look back there, how did we get the x squared, the n squared, and the t squared? What had to go right here and right there? Marker. Right, our variable went there. Right? So when it was n squared, there was an n to n. When it was t squared, it was t and t. In this case, it's x squared, so it's x and n. Justice, what's up? Did your hand up? All right, so then look back to the pattern that we talked about that Enrique and Allie told us. Ask yourself, how do you get the 10 and how do you get the 9? So don't answer what they are for this one, but Allie, just refresh us. How do you get the 10? Just generally speaking.
You add the constant.
You add the constant. Good. And then Enrique, how do you get the 9? You multiply the constant. So what you need to figure out, two numbers that multiply to 9 and add to 10. So you need two numbers that multiply to 9 and add to 10. Enrique? X plus 1, x plus 9. We're undoing distributive. Yes. Backwards. Yes, we're moving backwards. That works out. So let's check this and see if it worked out. X times x is x squared. X times positive 9 is positive 9x. 1 times x is plus 1x. And 1 times 9 is plus 9. When you combine it like terms, you get x squared plus 10x plus 9. So this is the correct answer. What questions do you have on our first example? Let's do that. X squared minus 5x minus 6. X squared minus 5x minus 6. Once again, think about what Justin told us. We know that it's going to factor down into two binomials, so go ahead and get your parentheses right there. Then think about what Marco told us. How do you get x squared? Well, it's going to have to be an x and an x. And then think about what Alan and Enrique told us. We get to negative 5 by adding, and we get to negative 6 by multiplying. Go ahead and try and figure out what needs to go in the green blank. Work with your partner, try and figure out what two numbers, when you add them, are going to give you negative 5, and when you multiply, we're going to give you negative 6. Multiply to negative 6, add. No. It's right here. That doesn't work. So it's the other way around. 13 and 30. Would it be x plus 6 and then x minus 6? Maybe x plus 6. I know, but like, what you write? X. I did a whole. Yeah, look at that. And I can go You disrupted my learning process with what? That would give you like positive 5 and negative 1. Yes. Got it. No. You're gonna multiply out and check yourself. All right. If I have your attention, please, thank you. So a lot of you immediately, you look at 6, you look at 5, and you're like, 2 and 3. All right? And so if you did that, you can come here. Okay, how is the thing? You didn't do this, you just lock it. You can lock it there. No. No? All right. So if you're taking a look at this, all right, and a lot of you hopped on 2 and 3 right away. And then from there, you're like, well, I know maybe they're both negative. Because negative 2 plus negative 3 is negative 5. The problem is that negative 2 times negative 3 is positive 3. So this setup doesn't work. So then maybe you're like, well, maybe it's negative 3 and positive 2. Because that gives me negative 6, and that gives you negative 1. So that doesn't work. Right? So what you're doing here is you're guessing and checking. So maybe you try negative 1 and positive 6. You're like, well, that gives me a negative 1 when I multiply. That's it. So then you did x times x is x squared plus 6x minus 1x minus 6. You got a positive 5x. You wanted a negative 5x. So all you have to do is just switch it out. It's going to end up being a positive 1 and a negative 6. X times x is x squared. X times 6 plus or minus 6x. Plus 1x minus 6. So that is correct. So a lot of you are writing down an answer, and you're looking at me and being like, it's x minus 2, x minus 3, right? Just check it. Don't be lazy. Check your work. Next one. X squared minus 8x plus 15. X squared minus 8x plus 15. Please make sure we're copying down problems, even if we're not trying to do them on our own yet. Think about what Justin told us to do. How are you going to start it? Think about what you can start filling in. What Marco told us. I wrote a photo that I sent it through. Oh my God. Oh, hey, Alex brought up a good point. If you saw it at Moto, quite a few you didn't turn in product number 3. I wasn't sure it was confusing that you had till Friday at 1. Like, I wasn't sure what Friday. I just got on the bus. Or, so I extended it till today. So it's due at the end of the day. So you can turn it in right now. If I have your attention, please. And thank you.
I should mind it, right?
We'll try again. If I have your attention, please, and thank you. All right. Nick, what'd you get?
I got it.
Is there any difference between x minus 3, x minus 5, and x minus 5, x minus 3? No, there's no difference. If you were to multiply both those out, you get the same thing. Ooh. Try that one. X squared plus 3x. Think about what's missing, what you need to fill in. It's causing me way too much of a headache.
I'm sorry, what?
Get rid of the pencil.
Oh, I lost my phone.
Is it like a letter?
So what's 1 plus 3?
I got the answer.
Third was add 3, multiply, what's that? Yeah.
What's happening? What's happening?
After 3x, what is out? How do you represent nothing that matters? So how do you multiply the 0 and add the 3? What's the number you're supposed to do? I'm doing the robot as well. Yes. Yes. Okay. So multiply that would be easier for what? Okay, so there's nothing there at your parents' house. So it's 0. Right? Multiply 0. Multiply 0. Add the 0. All right. Yes. If I can have your attention, please and thank you. All right. So for those of you that got it, I really feel like I don't have to talk to you. But for those of you who are having trouble, so this is missing the last term. So mathematically, when you're missing something, represent it with a 0. So you just want to ask yourself, well, how do I multiply the 0 but add to 3? Well, that would be 0 and 3. Now, look at this right here. Do we need the plus 0? No. Of course not. So we just write this as x times x plus 3. X times x is x squared. X times 3 is plus 3x. So that is factored correctly. So instead of going through this route, instead from the very beginning, what do x squared and 3x have in common? They have an x in common, which is why we merely factored out an x to get that result. Why we just factored out an x. So it becomes x times x squared. Consider this one.
Big numbers.
5x squared minus 30x plus 25. 5x squared minus 30x plus 25. What are you doing?
It was payback. It was fair.
Okay, before you just jump into this, start doing math with your theory. What do you notice about this problem? They're big numbers. Do you notice anything about those big numbers, Chris? So we could take a 5 out. We could factor a 5 out. So let's start this problem by factoring a 5 out. Sure. So when you factor a 5 out, you get x squared, because 5x squared divided by 5 is 1. Minus 6x plus 5. So now, look at our problem. X squared minus 6x plus 5, we can factor that. Bring the 5 straight down, and go ahead and work on factoring that. Notice the 5 just comes down. We just factor the 5 out, like how in the last problem we factored an x out. Bring the 5 down. Look, multiply the positive sign and add a negative.
Not cutting it down is not a recipe.
Remember, you want a 5 on the end, not a 6. If I could have your attention, please, thank you. So, if you're looking at this, you just want to ask yourself, well, how can you multiply and get a positive 5? It's either positive 1 times positive 5, or it's negative 1 times negative 5. So positive 1 plus positive 5 is positive 6. You want a negative 6. So name x minus 1, x minus 1. So you get 5 times, when you multiply this out, you get x squared minus 5x minus 1x plus 5. So we factor this out. I have one more problem. You're going to put your answer in on your clicker. All right, take time, please. Find the who is number 9?
Click in.
Who is number 9? Number 9. Who? You hold down the button of the power button.
Number 9. Who's number 9 that already solved this? It was Michael. Everyone's gonna get it right. No, it was Jennifer Michael.
What do you want to choose, A, B, C, or D?
Oh, don't pick this. I can't see.
Yay.
You know what? Yeah. answer one time. I want you to tell you. All right, let's say, does anyone still need to click an answer? All right, let's give it another one. Closing it. Might have your attention, please, thanks. See how we did here. Good? All right, so there were about 5 of you who did not get it right. Let's see if those 5 people can get our last problem of the day right. Everyone got it right with the last problem. All right, what is the answer to this? What is the answer to this?
Do we pick a distance?
Please click your answer in.
Wow, guys. How do you do this?
We did one like it.
No, when did we do it like this?
3 examples ago.
Yeah, but I was gonna be the one person typing. The answers never look like that.
There was one that we did. And look, just like I promise.
Right.
Did you rewrite the answer?
So it's looking for different projects.
40. Yeah, and I said, yeah, I said he's going to rewrite it.
Let's go.
Put it in the bin. Don't say what's put in the bin.
Oh, what the heck? I don't get it. They don't like this.
I feel like Enrique has this conversation with himself.
Oh, wait, this is easy. Oh, it's A.
About 10 seconds. Maybe 5, actually. Yeah, we did.
Wait, hold up. We got one person. Dang. Oh,
Very nice.
How many people was that? Like 7?
oh,